Hello everyone, welcome to our today's lesson. I am so glad you are there, ready to dive into another exciting topic. It's about how to calculate the percentage yield. Okay, whether you here to strengthen your understanding of this topic or another one, or get ready for your next exam, I am here to guide you step by step. Let's start. What is meant by percentage yield? Percentage yield, a measure of the actual yield for one of the product, okay, in a chemical reaction when carried out experimentally compared to the theoretical yield calculated from the equation. Here, two yields, actual yield, okay, and theoretical or calculated or expected or predicted. So we have two yields, actual, okay, and theoretical. From this equation, we can obtain the percentage yield. Percentage yield equal actual yield over theoretical yield times 100 times 100%. Okay, let's start the first problem. Copper 2 carbonate is broken down by heating to form copper 2 oxide and carbon dioxide gas. The equation for the reaction is shown. Copper carbonate decomposes this type of reaction called thermal decomposition. Copper 2 carbonate decomposes by heat into CuO, copper 2 oxide, plus CO2. Okay? According to this equation, here we used 31 grams of copper 2 carbonate are heated until all of the contents of the test tube have turned from green to the black. All 31 gram as a mass of copper 2 carbonate used up. Okay. Now the yield of copper 2 oxide CuO formed is 17.5 gram. What is the percentage yield? For four choices A, B, C, or D. The first idea, how to change the masses used in this problem, okay, into MR, and also then change into number of moles. So step by step. Let's start firstly for MR, how to calculate MR of certain compound by looking to a periodic table. For CuCO3, look please, Cu, it's AR, relative atomic mass equals 64, for carbon equal 12, for oxygen equal 16. So MR, molar mass of copper 2 carbonate equal 64 plus 12 plus 3 times 16. The sum equal 124. The same method used also to calculate the MR of CuO, copper 2 oxide. Here, molar mass of CuO equal 64 plus 16 equal 80. This is the first step. Calculation of MR of both compounds. One, the reactant that decomposes, I mean copper 2 carbonate, obtained from this equation. Now, here, moles, how to change MR to moles? What's the relation between MR and the number of moles? Here, according to this triangle, look please, number of moles, okay, where, yes, number of moles equal mass used given mass over MR, So, to calculate number of moles of CuCO3 used in this problem, and we used mass over molar mass equal 31 gram. Where is 31 gram? Here, 31 gram of copper 2 carbonate, look, 31 gram over 124 gram as MR. The result equal 0.250 mole. Okay. This is the number of moles of copper 2 carbonate used in this decomposition. Now we need to change number of moles into mass, into grams. How come? By this triangle, okay, we use what? We use the mass equal number of moles, okay, times MR of CuO. Look here, the predicted, theoretical, calculated mass of CuO equal number of moles, I mean 0.250 times 80, here 80 equal 20 gram. Last step, percentage yield equal what? Actual yield divide theoretical yield times 100. Okay, so equal what? Equal, okay, 17.50 here, okay, 17.50 obtained already from this decomposition, divide theoretical math of CuO according to the equation, okay, times 100 to obtain percentage equal 87.50%. So the answer is D. It's okay? Okay. Number 2. When heated, copper 2 oxide, CuO, reacts with ammonia, NH3, okay? 3 CuO, 3 moles of copper 2 oxide, plus 2 moles of ammonia, reacts to give 3 moles of copper as metal, okay, as element, plus nitrogen, plus 3H2O. 8.5 gram of ammonia reacts with an excess of copper 2 oxide, okay, to produce 26.4, this actual yield of copper. What is the percentage yield of copper in this reaction? As the first problem in steps, we need periodic table, okay, to calculate molar mass of ammonia and molar mass of copper, or relative atomic mass of copper. So for molar mass of ammonia, N with mass 14 plus 3 times 1 for the masses of 3 hydrogen atoms, so the total equals 17. Molar mass of copper equal 64 according to table. Moles of NH3 used, here we use 8.5 gram only, okay? So mass over MR to give number of moles. Mass over MR, okay, to give number of moles. 8.5 grams used over MR of ammonia equals 17, so equal half a mole, okay, of ammonia. Now, with the same concept, we return to the equation. The equation shows what? Shows 2 moles of ammonia reacts to give 3 moles of copper. This ratio 2 to 3, okay, between the reactant that is used up, like ammonia, and the product we need to calculate its percentage yield in this problem. So 2 moles to 3 moles. But actually, we not used 2 moles of ammonia. Only we used 0.5. Okay? 0.5 mole. So what about number of moles obtained according to the amount used up of ammonia equal X mole? By cross multiplication, we can obtain number of moles of copper obtained or produced. 3 times 0.5 divide 2, cross multiplication, divide 2, so equal 0.75 mole of copper. Now, return back to what? Return back to how to change this number of moles of copper into mass per gram from this equation, from this triangle. Okay, number of moles, okay, times MR to give the mass, predicted mass according to equation. So the expected theoretical mass, calculated mass equal number of moles 0.75 times MR. I mean here 64. So this equal 48 gram. That's theoretical mass. Where is the actual here? So actual divide theoretical times 100 to give percentage yield. Okay? Percentage yield equal actual yield over theoretical yield times 100. We compensate with numbers, with figures. Log times 100 equal 55%. So the answer is C. Okay? Now with the third problem, 90 gram of glucose is dissolved in water. The glucose solution is fermented. Glucose is fermented into 2 moles of carbon dioxide, 2 moles of ethanol. Glucose MR equal 180 gram, ethanol MR equal 46. Okay, this is the MR for both are given the data for this problem. After the fermentation finishes, 6.8 gram of ethanol is obtained. Here, this actual yield, okay, actual yield from the solution. What is the percentage yield of ethanol? According to the equation, from the equation, given equation, here glucose, okay, 1 mole of glucose fermented to give 2 moles of what? Of ethanol. So the ratio 1 to 2, 1 to 2, okay? The ratio between glucose and the ethanol, 1 to 2. Already we not used up 180 gram, only we used up 90 gram. This actual used mass of glucose. This expressed by half a mole of what? Of glucose used. So we obtain 1 mole of ethanol. Why? Because if we use complete 1 mole of glucose, we obtain 2 moles of ethanol. Now we used up 90 gram. 90 gram equal half a mole. So we obtain 1 mole of ethanol. Okay? Look, please. What about X gram mass of ethanol produced by cross multiplication? We can obtain this. Okay? 90 times 46 divided 180 equal 23 grams. Okay? This theoretical or calculated yield according to equation. Now for percentage yield equal actual over theoretical times 100. Compensate. 6.8 gram obtained over what? Over 23 times 100 equal 29.6%. So the answer now, the correct answer is D. Okay. Thank you.